They want us to graph a rational function where the function is less than or equal to 0, from negative infinity to 0, and also from 3 to infinity, including 3, but not including 0, and where it's greater than or equal to 0, from 0 to 3. So we know right away that at 0, there has to be probably a vertical asymptote. And we also know that at 3 is going to be an x-intercept. I knew that 3 had to be a VASI because it says that it's not equal to that. So the simplest way to do that is just to make a vertical asymptote. You could also probably do removable discontinuity and different things like that, but that's probably the easiest way to do it. So I'm thinking that my graph has to be, draw it in here real quick. The graph at 3, 1, 2, 3, there's got to be a point, and it's got to be smaller than 3, from 3 to infinity, inclusive. So it's going to be like, the function value has to be negative starting at 3, so it's going to be something like that. And you could just make it a straight line if you wanted to. That's either way, it's going to eventually get there, right? And then it also has to be greater than 0 from 0 rather to 3, not inclusive. So it's going to have to do, whoops, didn't mean to do that. It's got to be like this, where 0 is an asymptote. And then it's got to be less than 0 from negative infinity to 0. So the easiest thing for me to think of is just to do that right there. So that function is going to be less than 0. The function value is less than 0 anytime you are left of 0. When you're at 0, there's no function value, so it's neither greater than nor less than. And it's only greater than 0 between 0 and 3, including 3, but not including 0. And that's because it said the equal to sign for both of those. So that would be an example. Not the only one, but certainly a good example.